Hello, in this video we are going to learn about completing the square. It's going to be our second method for solving quadratic functions. So what does completing the square mean? Well, completing the square is useful because we can use it to solve a quadratic whenever we can't factor and whenever we cannot graph. We haven't learned how to graph yet, but we did learn how to factor in the previous video. Now, for completing the square, your function must be in the form ax squared plus bx equals c. So for factoring, we had to equal 0. In this case, I want your constant on the other side. Our saying is going to be half it, square it, add it. And when I say add it, I mean to both sides. But you'll hear me say that frequently. Half it, square it, add it. A must be 1. If it is not 1, then you're going to divide everything by a. We'll see an example of what that looks like. So example 1, we're going to solve the quadratic function by completing the square. Our function is x squared plus 6x plus 8 equals 0. So here are our steps. The first thing we want to do is we want to move c. Our c is 8. So to move 8, we need to subtract it from both sides, producing 8 squared plus 6x equals negative 8. So now we've moved c. Now, is a 1? Yes, we have a plain x squared, so a is 1. Now we need to identify our b, 6. We're going to half it, which is 3. So now we've halved it. We're going to square it, which is 9. And we're going to add it to both sides. Now it is time to solve. X squared plus 6x plus 9 equals 1. And to do this, we're going to factor the left-hand side. What factors of 9 add to give us 6? Our two factors of 9 are 1 and 9 and 3 and 3. 1 plus 9 equal 10, because remember, the plus sign in front of the 9 tells us to add. So 1 plus 9 gives us 10, but 3 plus 3 gives us 6, which is what we were looking for. So we're going to use 3 and 3. Remember, for factoring, we put both of these over ax, and then to fill in our parentheses, bottoms up. And because both 3's were positive, plus signs are going to go in between. Now, a way to rewrite this is x plus 3 squared, because our parentheses were the exact same. Now, the inverse operation of squared is square root. Anytime that we write the square root, anytime it's not printed in the textbook, listed on your form, seen on your screen in Schoology, anytime that you have to write the square root down, you have to do plus or minus, because we don't know if we squared a positive number or a negative number, so we have to account for both cases. Now, the square root of 1 is 1, so we know that x plus 3 equals 1 and x plus 3 equals negative 1. That's the positive square root and the negative square root. Solving for x, we're going to subtract 3 from both sides, so x equals negative 2 and x equals negative 4. So those are our two solutions to x squared plus 6x plus 8. Example 2. Still using completing the square, but this function is more complicated. 8x squared plus 16x minus 74 equals negative 10. Here are our steps. First, we need to move c. So we have a negative 74. We need to add 74 to both sides. So now we have 8x squared plus 16x equals 64. So now we've moved c. Now, we know that a is 8, but we need a to be 1. So we're going to divide everything in this function by 8. That's going to leave us with x squared plus 2x equals 8. So now a is 1. Our b is 2. We need a half b, which is 1. We're going to square 1, which is 1, and we're going to add it to both sides. So now we have x squared plus 2x plus 1 equals 9. And factoring x squared plus 2x plus 1, we get x plus 1 and x plus 1, because the only factors of 1 are 1. We can rewrite that as x plus 1 squared. The inverse of squared is square root, but because we are writing it on the paper, we must include plus or minus. And the square root of 9, the plus or minus square root of 9 is positive 3 and negative 3. Subtracting 1 from both sides, I get x equals 2 and x equals negative 4. So now we have solved this quadratic function by completing the square. That concludes this video for completing the square. In the next video, we're going to learn about the quadratic formula, my favorite.